Welcome to qnawire.
With half-life, you've probably been introduced to the formula or a version of it, like some final amount is equal to some initial amount times exponential base e to some constant times t, where t is in years, k is some constant, and again, a final and initial amount. So with half-life, we know that when we, just in general, doesn't matter how much you have to start or finish, but we know that um, when we divide the initial amount, we get half because that's what half-life would be. So we get 0.5 equals e to the kt, and we know for this it takes 60 years to have half. So we have 60 times k. What you do is take the natural log to both sides because that's going to counteract the exponential base e. We have the natural log of 0.5 equals 60k. And then we divide both sides by 60, and that is our constant k. And the natural log of 0.5 divided by 60 is negative, I'm going to go to 4 decimal places, negative 0.0116. Actually, I'll go to 5. Negative 0.01155. Might not make much of a difference, but what we're doing here is helping to develop a formula. We want to know how much of the substance will remain in 200 years, okay, if we're starting with 100. So our initial amount is 100 times e to the k, which we just found, 0.01155, t, which is 200, because we want to know how much of this will we have after 200 years. And so 100 times e to the negative 0.01155 times 200 means after 200 years we'd have about 9.93 grams of the 100.